Welcome to the video lecture series for the diploma second semester students. Our subject is applied mechanics and our topic is work, power and energy. In this second lecture I welcome you again all. So in last lecture we have studied about somewhat work. What is work, what is unit? So let us revise what we have learned in last lecture. So what is work? So whenever a force acts on a body, work is said to be done if body undergoes a displacement in the direction of force or component of displacement is in the direction of force. So work done is nothing but F into D, where F is equal to force and D is the displacement. We can define the work more precisely. If work is equal to W, then W is equal to force multiplied by displacement component in the direction of force. So work is equal to F cross D cos theta, and in form of vector, work is equal to vector D F dot vector D. So let us understand this thing again. Suppose one object is lying on a surface and one force is given if it displaced by distance s in the direction, please check, it is in the direction of force. So work done is equal to F multiplied by S. Suppose if object is here and we are giving the force angle theta with horizontal and this object moves by distance S, but you can see that direction of the force is somewhat theta degree with horizontal and movement of the object is in horizontal direction. So direction of the force and displacement are not in same direction. So here only horizontal component of this force, which is F cos theta, we have to consider, and actually work done is nothing but F cos theta into S or D. So you can visualize these things from this figure. So here also F cos theta component and vertical component is F sin theta. So we have to consider only F cos theta component, which is in the direction of displacement and which is actually responsible for work done. So what is the unit of work? So work is F into D. F is equal to force, which is in Newton, and D is the displacement, which is in meter. So naturally unit of the work done or work is Newton meter. If 1 meter displacement of a body takes place under the direction of force under the action of 1 Newton force, 1 joule work is done. So let us understand this thing. Suppose we are applying a 1 Newton force here and body displaced by distance 1 meter. So work done is equal to 1 Newton multiplied by 1 meter. So that is 1 Newton meter, and 1 Newton meter is nothing but 1 joule. Work is a scalar quantity. We have also discussed some cases of work. Suppose force is in this direction, here to here, and displacement is also in the same direction, then work done is equal to F into D, or F cross D. Let us see the case of friction force. Here friction force is in this direction and displacement is in opposite direction. So force is from here to here and displacement is here to here. So theta is 180 degree. So cos theta is -1 and work done is minus FD. So negative work done is said to be done. Work done against the force. Here we have seen that if one person is having the weight in his hand and gravitational force acting is on vertical direction, but he moves in a horizontal direction. So angle between these two is 90 degree. Force is in this direction and displacement is in this direction. So work done here, even though he moves from this place to this place, work done against the gravity is nothing but 0. No work done. So in last lecture we have calculated some example. So let us continue this thing with this understanding. So one example is a horse is pulling a cart at a constant horizontal force of 500 Newton at a speed of 5 km per hour. Find the work done in 20 minutes. So here it is the case of constant force. It is a case of constant force, and as we know that work done in constant force is nothing but F multiplied by S. So first of all we have to find out the displacement S. Velocity is 5 km per hour. So we have converted this kilometer into the meter, so that is 5000 meter, and this hours is 3600 second. So speed of this thing is 1.38 meter per second. And we have to find out the work done in 20 minutes. So total 1200 second is there. So distance travels in 1200 second is velocity multiplied by time. So 1.38 meter per second is the velocity and 1200 second is the time. So total distance travel is 1656 meter. So now thing is very easy. So what is work done? It is force multiplied by distance. So 500 multiplied by 1656. 500 is the force and 1656 is the total distance travels in 20 minutes. So total 828000 Newton meter. So we can say this much joule work done is reported. So let us take another example. Free length of a chest expander spring is 100 centimeter the stiffness of the spring is 5 Newton per centimeter of stretch. The bodybuilder stretches the spring by 50 centimeter, that is the stretch length is 50 centimeter. Find the work done by bodybuilder in joule. So very interesting example. So it is the example of spring now. So we have discussed in the last lecture, suppose if spring is stretched initially, the force is 0 and we apply F force is equal to F. Here it is the stretch length. If suppose stiffness of the spring is the K and total work done is 1/2 K delta L square. So you can recall this thing. It can be also explained by graph force versus displacement. Here initially force is 0, then we are applying the force and it is F. The work done is equal to area of this diagram, that is 1/2 F into delta L. So that is 1/2 K delta L square, because F is nothing but K delta L. K is the stiffness of spring and delta is the displacement or stretch of the spring. Here deflection is 50 centimeter. Stiffness of the spring is 5 Newton per centimeter. That means for stretching the spring 1 centimeter we required 5 Newton force. So K is equal to F upon delta. So F is equal to nothing but K into delta. So total force we are applying 5 into 50, that is 250 Newton. So as we have discussed that initially force on the spring was 0 and then after it reaches to F, and because of this delta L is produced in the spring. So we have to consider average force. First is 0, then total from 0 to 250 divided by 12 is equal to 125 Newton. So work done is nothing but average force multiplied by displacement. Here delta is equal to 50 centimeter, that is 0.5 meter, and average force is equal to 125 Newton. So total work done is equal to nothing but 62.5 Newton meter, that is 62.5 joule. Let us take another example. A locomotive pulls a train with a uniform velocity of 50 km per hour and exerts the attractive pull of 20 kN. Calculate work done by locomotive in 15 minutes. So let us understand this problem. locomotive is pulling the train in this direction, and speed of the locomotive or train is 50 km per hour. Pull is 20 kilonewton. So we have to calculate the work done in 15 minutes. 15 minutes. So here velocity is 50 km per hour. So we have converted this into the meter, and that is 50 multiplied by 1000, and this is the second, 3600 second per hour. So that is 13.89, 13.89 meter per second is the speed of train. We have to find out the work done in 15 minutes. So total 15 multiplied by 60 is equal to 900 seconds. So we have to find out the work done in 900 seconds. Distance travels by the train is equal to velocity multiplied by time. So we are having the velocity is equal to 13.89 meter per second, and t is equal to 900 seconds. So total distance traveled by the train is 12,501 meter. As we know that force is equal to 20 kilonewton, that is 20 into 10 raised to 3 Newton. So work done is equal to F into S. So that is 20 into 10 raised to 3 Newton multiplied by distance travelled 12,501 meter. So that is 25 into 10 raised to 7 Newton meter. That is 25 into 10 raised to 7 joule. Work done is reported. Let us take another interesting example. A woman pull water by bucket from a well of 20 meter depth. The bucket is having the small hole and is leaking uniformly. When bucket is full of water, its weight is 200 Newton, and at the top of well its weight is 100 Newton. Calculate the work done by a woman in pulling one bucket of water. Neglect the weight of the rope. So it is another interesting example. Suppose this is the well and here is the bucket. We are pulling the bucket here. So at initial stage it is full of water, and due to the leakage, when it reaches at the top, some water is, due to the leakage, the bucket will remain empty. So it is the case of variable load. It is the case of variable load. So first of all we have to find out the average force. So how can we find out? Let us see. Initial weight of the bucket F1 is 200 Newton. Final weight of the bucket is 100 Newton and average weight is nothing but 200 plus 100 divided by 2, that is 150 Newton. Let us understand. Suppose here the weight was 200 Newton and at the top it becomes 100 Newton due to the leakage of the water. So weight of the bucket is reduced from 200 to 100 Newton. So average force is 200 plus 100 divided by 2, that is 150 Newton. 150 Newton. And height of the well is 200 meter. So work done is equal to F multiplied by S. So that is average force 150 multiplied by 20, that is 3000 Newton meter. So we can say work done is 3000 joule. Let us discuss another example. In a construction of concrete dam of 60 meter height, concrete is lifted from the base of the dam by a bucket 5 kN and rope of weight 70 Newton per meter. Calculate the work done in lifting one bucket of concrete. Here also this is another example of variable force. Suppose a concrete dam is there and as you can see height is 60 meter, and when the bucket is there for the height of 60 meter, total weight at the bottom will be the weight of bucket plus this weight of rope. But at the top of the dam it will be the only weight of bucket. So it is the case of again variable force. So how to calculate? Weight of bucket is plus 60 meter long rope, because as we can see that weight of the bucket is 5 kilonewton and weight of the rope is 70 multiplied by 60 Newton. So total 5000 Newton plus 4 to here it is 5000 Newton plus 4200 Newton, that is 9200 Newton at the bottom, because we have to consider entire length of the rope. At the top of the dam, weight of the rope is 0. So only weight of the bucket we have to consider, that is 5000 Newton. That is 5000 Newton. I think things will clear to you. So average force at the bottom of the dam, it was total weight was 910 2 Newton, and at the top of the dam is 5000. So F average is nothing but it is divided by 2. So that is 7100 Newton. So again, work done is equal to average force multiplied by displacement, and that is 7100 multiplied by 60. So 426,000 Newton meter, and that is 426,000 joule. So far we have discussed about work. So one question arises: what is the work done if the earth rotates about its sun? So let me give the answer. It is 0. So it is your homework to find out how it is 0. So up till now we have discussed many things about work, how work done is been calculated, and we have taken many examples regarding work done. So things about work must be clear to you. In this chapter we will discuss power, because our chapter is work, power and energy. So what is power? Let us see the thing. Power. The quantity work has to do with a force causing a displacement. Work has nothing to do with amount of time, that is force acts to cause the displacement. Sometimes the work is done very quickly, and other time the work is done rather slowly. Because up till now in this discussion we have not incorporated the factor time, because work done we are only concentrated on work done. Suppose 700 joule is work done, but we have not bothered in how much second or how much minute work done is done. But in the case of power we have another quantity, time is incorporated. Let us see. If we take the example of two employees of the same company doing the same work, one completes its work in 5 hours and another employee completes the same work in 9 hours. Which one would you prefer for that work? Because both are doing the same work, so we can say both are capable of doing that work, but one completes the work very quickly and one completes its work with a slower rate. So now meaning of power must be clear to you. Now we are going to define another quantity called a power, which correlates amount of work done with time. The time rate of doing work is known as power. Power is defined as work done per unit time. So P is equal to work done plus time taken, and it is W upon T. Power is the scalar quantity. So far as we have discussed work done. Work done is nothing but F into S or F into D. But now another term for the work done, how much faster or slower this work done is calculated by means of quantity power. So power is nothing but work done upon time, and naturally work done is Newton meter and per second. The unit of power is Newton meter per second. Let us check. SI unit of power is joule per second or Newton meter per second, called watt. Generally, kilowatt hour or horsepower are used as unit of power. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 watt, and 1 horsepower is equal to 746 Newton. Let us again discuss this thing. Power is equal to work done upon time. So we know that work done is equal to Newton meter, so that is Newton meter or joule per T is equal to time. So unit of the power is joule per second or Newton meter per second, and for this entire quantity we can say watt. So what is the 1 watt power? Is nothing but 1 Newton suppose we apply a force 1 Newton here, it displaces by 1 meter in 1 second. So here quantity second comes into the picture. So 1 watt power is said that because 1 Newton 1 meter upon 1 second, so that is 1 watt. That is nothing but 1 watt. And one important thing is, you can see here, because in day-to-day life we are using power in terms of horsepower. So 1 horsepower is nothing but 746 watt. Again, 1 horsepower is nothing but 746 watt. Most machines are designed and built to do work on object. Any machines you can see. All machines are typically described by a power rating. The power rating indicates the rate which that machine can do work upon other object. Thus, the power of a machine is work upon time ratio for that particular machine. One excellent example in day-to-day life we are using, that a car engine is an example of a machine that gives the power rating. The power rating relates to how rapidly the engine can accelerate the car. In advertisement also we can find out that our car reaches up to 100 km per hour in 15 seconds or 10 seconds. So it depends upon the power of the engine, because work done is nothing to do with time, but when power comes into the picture, the time is the important factor. We have seen some people or machines are more powerful than others. That is, some people or machines are capable of doing the same amount of work in less time or more work in the same amount time. So it is very clear now that if some person is doing the work in 1 hour and some person is doing the work in half an hour, the another person is more powerful than, because both have done same work, but another second one has completed his work in less time, so second person is more powerful. So expression of power is work upon time, and since the expression of work is force multiplied by displacement, the expression of the power can be rewritten as force multiplied by displacement upon time. So power is nothing but force multiplied by displacement upon time. Now displacement upon time is the velocity. Displacement upon time is, we all know that displacement upon time is nothing but velocity. The power is, can be written as force multiplied by velocity, because, please clarify this thing, power is equal to force multiplied by displacement upon time. So displacement upon time is nothing but velocity. So we can say that power is nothing but force multiplied by velocity also. So power is equal to F dot V in the term of vector terms. So this equation, new equation of power, reveals that a powerful machine is both strong and fast. It can define, because it is either big force or big velocity, it can be defined as capacity of doing work. Again, see here, power can be increased with force or velocity. If some machines are capable of applying more force but with less velocity, then it is not a powerful machine. So both the factor we have to consider, force and velocity. So in this lecture we have discussed somewhat about power, and in next lecture we will take the example regarding power, so things will be clarified. I hope up till now you have cleared doubt about work and power. Thank you.